Okay, it's now live. And so, well, hello everyone. Welcome. It is 6 o'clock on Wednesday night, March 3rd, and we have an incredible treat for you all this evening. My name is Ann Gatling, and I am the STEM Ed co-director here at Merrimack College, and I teach the Science Methods course for elementary and pre-service teachers. And we have a beautiful guest who just has brought so much to our campus. And so to get us started, before I introduce him, what I am going to do is share with you just a little bit about how this journey began and brought us to this evening. So let me share my screen. So we have a timeline today. And this is an incredible timeline in which I share where I sort of started my own Mars journey. The first stop was here at the Framingham State Street STEM Festival. And this was held in April of 2019. And there were a group of gentlemen who had this contraption that they said was going to go to Mars at some point, and it was going to transform or take carbon dioxide and turn it into oxygen on Mars. I thought, well, that's kind of interesting. And just by happen chance, someone else who had a display at this festival for my daughters and I was our own Merrimack College physics professor, Doug White's son, who had a wind turbine that was creating light, I believe. And so anyway, it was just so neat, all these connections that have been made around. And then that summer in June, Touch Tomorrow Festival, it's been going on for years. They had, Piyush was there. It was the first time I actually met him, and he had tickets that we could get to, let's see if I can show it, tickets to go to Mars. So Isabella and Caroline and I had tickets to go all the way to Mars, and Piyush helped us to sign up for that. And I just so enjoyed him and meeting him and coming to know him. And I thought, well, maybe he could come and speak at our own Moon Over Merrimack festival that we have once a year. We've had it. This was our third year. And so he said, well, yes, I think I could. And so for our second Moon Over Merrimack, here is a picture of Piyush and Sam, one of our STEM Ed majors, talking about some things around Mars and everything at our Moon Over at that festival. And that was in 2019. And then our second, and also in our second Moon Over Merrimack, we had the Mars map, and the kids were able to use B-bots and M-bots to code them to go across from crater to valley to whatever. And so it was really quite fun. That was in October of 2019. And then this year we did it virtually. And if I can show it, Piyush was able to talk to us and tell us a little bit about what was happening with Mars and Perseverance. And he had a map. And I remember him talking about this map with the little Mars rover going from Earth. And he said it took forever to see it leave Earth. But once it started to leave, then suddenly it was out there, and suddenly now it's closer to Mars. And he says, I'm going to come back and I'm going to share with you the things they're doing on Mars. And guess what, everyone? Tonight's the night he's going to tell us about what is on Mars and what is happening up there since it's landed. And so let me stop sharing. And with that, here I have Piyush Khopkar for you, a space ambassador, and so much more. I'll just let him explain that a little bit if you don't mind. And I hope you all enjoy. Now, when he finishes, he has some slides for us. When he finishes, I would love for you to put in the chat any questions that you might have. But right now, what would be helpful for us all is if you had, let's see, I have a chat here. Let's see. Oh, yes, we have. Right now, if all of you could put in the chat where you are, like what town, and how many of you are watching us. That would just be fun to see. Where are we reaching this evening? Anyway, with that, Piyush, take it out. Let's see what we have.
Thank you so much, Anne. So let me start sharing my screen. All right, let me know when you see your screen.
I can see it.
Sorry, let me know when you see my screen.
Uh-huh.
So let's play from the start. And you can see it, right?
Yes, thank you.
All right, so let's begin. So I think since I was going to talk about the Perseverance landing, so I thought like this is the best video I can put to begin with. So can you hear my sound, by the way?
Yes, I can.
Okay. You can hear the commentary as well, right?
No, it's not. So when you go back, before you share, there's a little link at the bottom. So stop sharing. And then as you start to share, there's going to be a little thing that says optimize video for sharing. So so quit sharing. And then when you go to click the share, push up on that little arrow.
Okay.
Or as you start to share that video, at the bottom of the video, there should be two little things that you click, and it says optimize to show video and sound.
I clicked the share sound as well. Yeah.
Yeah, the sound. Okay, now try it again. Now we can hear.
Okay.
President is continuing to descend on the parachute. The initialization of terrain relative navigation, timing of the landing engines. He is about 90 of 4.2 kilometers. There's confirmation that the wind division system has produced a valid solution as part of terrain relative navigation. We have timing of the landing engine. Is 83 meters per second, about 2.6 kilometers from the surface of Mars. The confirmation that the back shell has separated. We are currently performing the divert maneuver. Current velocity is about 75 meters per second at an altitude of about a kilometer off the surface of Mars. Here in 50 Bravo. We have completed our terrain relative navigation. Current speed is about 30 meters per second, altitude of about 300 meters off the surface of Mars. We've started our constant velocity accordion, which means we are conducting the sky crane maneuver. Sky crane maneuver has started. About 20 meters off the surface. Looking signals from MRO. Tango Delta. Touchdown confirmed. Today, safely on the surface of Mars, ready to begin seeking the sands of past life.
All right. So I thought that was pretty cool, and I think the thing is like it's the first time we have ever saw like how actually landing happens on Mars. In the first part, you might have seen like it was a parachute deployment and actually like the sky crane maneuver, and then the sky crane actually like literally drops the rover down. So I just feel like it's so stunning, and I thought like this is going to be the first thing I think I'm gonna start my talk with. So. Oh, can you hear me?
Yes. Yes, we can hear you.
Okay. So with that, let me introduce myself. My name is Piyush Khopkar. I'm a part of the Moxie team. Moxie is one of the instrument about the Mars 2020 rover and part of the Mars 2020 science team. Also, I'm one of the solar system ambassadors, the NASA JPL Solar System Ambassadors. It's basically a program run by NASA JPL. It's a group of there are like hundreds of volunteers across the nation who share the excitement and joy of space exploration with everyone. So I'm just like one of the volunteers with the program. All right. So first things first, I thought like I would share this. So there are like anyone can go and download all the raw images from the Perseverance rover. Raw images means like anything that just comes down, it just get dumped at this location. So you can actually go and find all the images. I think I just like checked today, I think this evening, and there are over 4,000 images, 4,000 raw images for every day. So people can like download them and do like whatever they want to do, like do some image processing and like however they want to visualize. So I thought like that's pretty cool. So in my talk today, I'm going to talk about like two things. As Anne mentioned, I actually came here like last year when I mostly spoke about the launch, and then gave like a brief overview of what the Perseverance rover mission is and about its different instruments and everything. It was so, I mean, like there was like so much thing to talk back then, so we thought like we'll just break it up. So now I'm here to talk more about the landing. But again, like before going to that, just like a quick overview of the Perseverance, the Mars 2020 rover mission. So we have had like a lot of like missions in past on Mars, like orbiters and rovers. And all past Mars missions have actually followed the water. Every like rover actually like we like build our knowledge on top of each other. Like we learned something from one rover, then we sent the other rover. We increased our knowledge, so our knowledge actually got increased, and we basically like followed water. Uh, there is a plenty of evidence that water actually flowed on Mars in the past, and we actually want to really answer this question from Severance Mars 2020 rover is uh, did Mars ever have life? Did we have the biosignatures that actually says that Mars actually had life? So to understand the possibilities of for life on Mars, we have like these four goals: the geology, astrobiology, sample caching, and prepare for humans. Sample caching. So I particularly like find like sample caching and prepare for humans like very uh, like like pretty cool. I mean, like I'm not saying like the other parts aren't cool, they are, but I just found like these two like pretty interesting. So sample caching is we are actually going to take the samples of Martian Mars and put them into the tubes, and then this rover would just like cache them. So initially it would cache inside itself, and then like based on I think some after some time we would just like put the cache the samples on the ground, and the idea is a future Mars mission would actually go there and then bring the samples back on Earth for further study. So that's one part, and prepare for humans. This is like one of the first step, I think, for actually preparing for humans. So in that goal, there are two experiments. One is the helicopter, which is the Ingenuity helicopter, uh, and the other one is an experiment called Moxie, which I'm going to talk about in detail later. But the idea of the Moxie instrument is to produce oxygen using the carbon dioxide on Mars. And I'm going to tell you why later. So again, like, it has these instruments, the Moxie, the surface radar, RIMFAX, the Mastcam Z. These are the cameras. The SuperCam, it's a laser micro imager. Beta is a weather station, so we will going to get like the weather. We'll get to know the weather on Mars. Uh, the Jezero crater, where actually the Perseverance rover landed. we have the Sherlock, the ultraviolet spectrometer, and Pixel on the robotic arm. So uh, I would like highly recommend to go back onto the raw images, and then there you would see there are like raw images from say I think Mask MC or like different cameras on the rover. So it's really pretty cool because right now it's just a picture here, but then when you actually see the pictures, like it's just like it's pretty cool. So as I said, like I'm going to cover two topics today. One is I'm going to talk about Moxie, and then I'm going to talk about how actually the Perseverance rover is getting operated from Mars and how we are operating Moxie. Because I think operating in a rover which is on a different planet, it's a completely like it's a very interesting journey. So I'm going to talk about that. So first, Moxie stands for Mars Oxygen ISRU Experiment. ISRU stands for In Situ Resource Utilization. So what we're doing with Moxie is it is actually inside the rover. It is housed inside the rover. What it does is it actually takes um, like carbon dioxide from Martian atmosphere. So Mars has almost like 97, 98% carbon dioxide in its atmosphere. So it takes the carbon dioxide and it actually produces oxygen. Now you would ask, one could ask like, why do you need oxygen? So we definitely need oxygen for breathing, right? I mean, once we are there, once humans are there, we need oxygen for us for breathing. So that's one thing. But that's not really what the purpose of Moxie is. The second thing we forget is whenever humans actually go on Mars, we are not. I mean, like I don't. If I get the chance, I want to come back. I don't want a one-way ticket to Mars, right? So when I want to come back, the thing is like when you really like come back, you need a rocket for coming back. And when it's rocket, you actually want to burn the fuel. And when you are actually really burning the fuel, so you need oxygen. And that is where Moxie is going to like help a lot because we are going to need a lot of oxygen for just coming back. So the idea is you would actually send, like again, this is an experiment on the rover. So we just want to see like how it works. Then the idea is like Mars has like different temperature, pressure during different time of the day. We want to see how we can operate Moxie different at those times. There are dust storms, huge dust storms on Mars. So that we also want to see like how Moxie operate in those situations. So again, like the idea is, let's say once we are ready, we are preparing for human mission, then we have like something like Moxie on Mars, and that would crank up the oxygen. It would produce the oxygen and it would store somewhere. And then once after some time, after some few years, then we as humans would actually fly from here, and basically by the idea is like by the time you reach there you would have like plenty of oxygen so that you can actually come back. So that's the idea. And again, like we are not like one thing is like we are not storing the oxygen we produce from oxygen right now. We just like measure how the purity of the oxygen, the oxygen is, and other things. uh, I think I should have mentioned this like very much earlier. If you have watched the movie The Martian, then the Martian movie talks about uh, a device called oxygenerator. If you know what that oxygenerator is, then you know what Moxie is doing. So it is kind of an oxygenerator. So this is it's a pretty cool picture of the engineers putting the this Moxie. It's a golden box in the Mars rover. uh, Few years ago, I think last year, uh, uh, at, and the JPL when they were like putting together the rover. So that was about Moxie. I will come back to just one more thing on Moxie, like at the end of my presentation. So let's see how the Perseverance rover is operated. So the thing is like the rover is there, right? And let's say operating, you have a robot. and then here on Earth, and then you want to operate it. So one thing could be like you can just like operate like I mean like you can just drive the rover like on Earth. Now the thing is like when the robot is on Mars, then you would need to follow like certain things so that it can actually work according to your schedule as well. So what that schedule is, but so it's just kind of a sweet story for a day in the life of a rover. But now we take a soul. So a soul. This image, by the way, I think it was the Curiosity Mars rover recorded this sequence of views. It shows like the sun is basically setting on Mars. So so one Martian solar day is called as one sol, one SOL, and the duration is 24 hours, 39 minutes, and 35 seconds. Okay. Now what happens is uh, when the rover wakes up, yeah, you would you would find it funny that the rover does sleep. I mean, like if it is waking up, then it does sleep, right? So the idea is when the rover wakes up at the start of a sol, so again, like at the start of a day, um, uh, we actually send the bundle of funds. So what we do is um, we actually like put together some say instructions, as in like you basically drive in this direction forward, or like uh, how many steps, and actually see this rock, then you basically take an image of that rock, or you extend your robotic arm, and then you have the spectrometer on your robotic arm, then you basically extend your robotic arm and then take a picture there, and like make some samples or do some experiments. So those all things are actually put together in a sequence as in like a set of instructions, and then we actually send all those things in a file uh, that will do next day when you sorry after you wake up. So that plan is sent directly to the rover from the Earth, and now rover gets that rover basically like carries out the entire sequences of activities which is commanded in the plan for the day. So I mean, like in this example, like in this graphics, the rover actually. So if you notice, like we drove, it was here. Say when the rover woke up. Sorry, we drove after certain distance. Then we extended the robotic arm, and then we took some like cool images, which we are seeing in the form of like the raw images. So uh, I shared previously, and then we lowered back the robotic arm, and then what happens is how do we actually get the data back, right? So there are orbiters around Mars. So what we do is the way the rover talks to us is it actually sends the data back to the orbiter, some of the collected data to the orbiter, and the orbiter actually records the rover data, and then it releases back to Earth. Then again, rover continues to carry out the sequence of activities which were commanded in the plan for the day. Night time. Um, well, everyone like to sleep. I think so does the rover. So a rover may continue to work at night, but most time it sleeps. And when it sleeps, it actually recharges its batteries. So the rover has a nuclear like power. So it basically recharges its battery using the nuclear power. And then again, like the rover wakes up for the early morning when the orbiter uh, like passes overhead, and then it again sends the data back to the orbiter, and then it relays it back to the Earth. So up until this point, we actually got the so basically no rover basically send the data to the orbiter. Okay, now the orbiter has the data. So let's see. Once data is with the orbiter, now it's the orbit is I'm like we need the data on Earth, right? So there are like a lot of people who actually work like it's a huge group who actually work on the operations like operating the rover. So we call it as like the technical operations team. So let's take a look at the day in the life of a technical operations team. So there are like bunch of people. They actually the team they actually reviews that what was, let's say, planned yesterday. Say we saw earlier in the picture that we wanted to drive some steps, and then we wanted to extend the robotic arm, take some picture, and then retract the robotic arm. So we actually review that what was planned for yesterday. Um, uh, then there are few people who actually work on the plan for next few days as well. And based on and we then there are like a lot of discussions going on, which basically like people decide like what exactly we want to do for like next few days. So here comes the downlink part. So we, if you remember, like the orbiter had the data, right? So now when the orbiter had the data, it actually sends the data back to Earth using big dishes called as the deep space network. So I think these are like dishes placed around like different parts of our Earth, the globe, and that's how we communicate to any orbiter or any spacecraft per se. One thing it's called as DSN, the Deep Space Network. One very cool thing about the DSN is you can actually go on, I can actually post the link later on the chat, but you can actually open the DSN website, the JPL website for DSN, and you can actually see which antenna is actually talking to one particular, I'm like, which antenna is talking at right at the moment. And you can actually see if it's like it's sending the data or receiving the data or what. So it's pretty cool. It's pretty cool. Um, I'm not sure if you've heard about the Voyager spacecraft that still talks to us. And sometimes, if you would notice, then one dish might also be talking to the Voyager spacecraft. So I feel like that's pretty cool to see that what exactly like happening in front of us. So the DSN, the Deep Space Network, gets the data, and then the data is getting processed because the data is in form of like zeros and ones. So you basically like the the data and then make it like human readable, and then create, say, data products like for some instrument. If it's, let's say, for some instrument it's one data, so it's kind of a data product. Then what people then there are people are on the downlink, so they are actually called as, say, downlink leads. So what they do is they actually do the downlink assessment. So they actually look at the data, like bunch of people actually look at different parts of the data, and they make sense of the data. And they actually, after making sense, what they see is, if, say, you wanted like few things to do from the rover, and once you get the data, you actually want to make sure that basically the rover is healthy, rover's health, and if it's safe, I mean, like if the rover is safe. So that's what the downlink assessment includes. And then it produces the, again, like science product. And again, the science product are again like handed back to the science team, which we initially saw. And the team review is that they actually looked at the science products. Again, like in this case, say it could be an image, or it could be a picture, which, like, again, like one of the pictures which is on the one of the raw images which is discussed. So once the team actually reviews the science data, or in this case if it's an image, then the team decide, okay, we should do next when the rover actually wakes up tomorrow morning. And this is again sometimes called as activity planning. So again, like this is an image of, I think, the activity which actually says that, oh, let's say when the rover wakes up, the rover needs to do this. Then after some time, say, run this instrument for this time. Then after some time, you actually do this. Then again, maybe after some time, you move forward. You basically drive forward or do something like other instructions. So, so again, like once you plan everything, and everything is like what you really need to do, and then we actually create a file. The file we actually saw very early when I was saying like the rover actually receives a bundle of file. So uh, we once we are ready, we actually send the file to the rover, and sending a file to the rover is called as uplink. So people actually generate the uplink file. You make sure like it looks fine, because the thing is, if you mess up, uh, uh, the earliest you can hear from the rover is the next day. So you want to make sure that whatever you are sending is properly validated and it's reviewed by multiple people. And then everyone, as I say, like the everyone in the team say like whether you go or no go. So everyone say okay go, and then upload the send the instructions to the rover, and like the same dish, it actually bundles, it actually sends the file to the rover, and again like this cycle continues. So that's how the entire process works. It was more of, it's pretty interesting because you get to see, you get the images, and then you basically make sense of what exactly you want to do uh, for the next day. So it's pretty interesting. Uh, there is one more thing, uh, is living the Mars time. So what happens is, by the way, there like Mars time, there is a very cool app. It's called as Mars 24. It shows you the Mars time, it shows you the Earth time. So you can actually select like which landing site you want to see. Say for the Perseverance rover, it's the Jezero crater. So I actually have it. I'll show you. I have it. Uh, I hope you can see it. So I have it like this is the current Mars time. This is the time of Jezero crater, where actually the Perseverance rover is. This is the Earth, and this is the local time, my local time in EST. Uh, so what happens is, like again, like Sol, uh, uh, to remind, it's a day, 1 day of Mars is called one Sol. So what we do is like when the rover sleeps, we saw earlier, it actually sends the data back. So that's when we actually people plan the things. So every day there are like different shifts. So the shift start time is actually pinned to when actually we are expecting to get the data. Link. And it is called as sorry, it is called as the decisional uh, time. Downlink for decisional means is based on that downlink, you need to make a decision of whether what you want to do for the next day. So the funny part is the downlink, it moves every day, and it moves every day because overflights and basically general drift of Mars. And what they, so in a nutshell, you started, say your downlink shift today at say 5 a.m. Then you would move that to 40 minutes next day. And then again, like 40 minutes next day. Again, like it depends on the orbiter overflights or how those things are going. But in general, uh, if someone, I'll come to that later. So that's called as Martian shift work is called as Mars time. So what people are doing is like many people, even in the Moxie team, like on Mars time. So they wake up sometime in the night, and then they sleep in the morning, because the idea is like at that time when it is night on Mars, you want to you want to do your work so that uh, when the rover wakes up, the rover has all the instructions what the rover needs to do. So it's funny because like and that changes every day, because if you say woke up today at say 9 p.m. in the night, you would do that tomorrow at 9:40, and slowly you would actually start increasing the 40 minutes every day. So similarly, like for the Sol n+2, I mean, like again, the next Sol, it's uh, uh, the time actually changes. So again, like the idea is like we try to make it like the shift between like 6 p.m. and 11 p.m. Pacific. Um, so uh, again, like this is how this is planned. In this case, it's like perfectly lined up with the Pacific time, that 6 a.m. in the morning, 10 p.m. in the evening. And when I say like it moves by 40 minutes, so now in this case, you might, if you notice, like the downlink actually moved a little bit, and that's why the 10 p.m. mark actually moved a little bit. But in this case, let's say we marked it to 10 p.m. and we just made the decision and we send all the instructions to rover by this time. But then there could be one time where we won't have enough time to make a decision for the downlink in this case, and then it's called as the restricted soul. So the idea is like you have to plan without knowing the outcome of the most recently uplink plan. So that's what the that's an overview of like people working on the earth time. And it's again, like as I mentioned, like it's challenging as well because your body needs to adapt to waking up like every day at different time. I mean, if you go to school, and easiest way to explain that to you is let's say you woke up today and then you went to school at 7 a.m. in the morning. Now tomorrow you went to school at 7:40 a.m. in the morning, and that's how you like added like 40 minutes every day. And again, like you are not coming back on the same time because you need to follow the entire school time, right? So you would be coming late as well. So there will be a time where actually you'll be going sometime in evening and then staying all the night in the school, and then you'll be coming back on the morning. That sounds fun. So that was about um, how the planning and how people do the Mars planning and planning for the rover, operating the rover in the Mars. When I was talking about Mars, I said like I will like tell one last thing about Moxie. Sorry, when I was talking about Moxie, I'll tell one last thing about Moxie. So like, Moxie is on Mars right now. The rover is on Mars. So you must have heard like the rover actually, like the helicopter and the rover, it actually phoned back on Earth saying that like, hey, look, I'm doing good. How is Moxie doing on Mars? So we also wanted to know when the rover reached last on February 18th. Then after we did get a call from Moxie, and what we got to know is Moxie is alive. So that's really good because that's a big step. Because the thing is, when actually the rover landed, you must like in the first video when we saw it, it actually travels from like Earth to Mars in that interplanetary phase. Then it lands and everything. So we all the first thing we will want to know is if the instrument is alive. So that's a big that was a great news for us that the Moxie is alive, so that we can start our operations. So again, like Moxie, I didn't mention it, but so Moxie is basically operated. It's brought to you by like MIT. It's built by JPL, and it's people and MIT are operating it. That's pretty much it from my end. Thank you so much for listening, and I'm happy to take any questions. So I'll probably stop sharing or all right. I think Anne, you are muted.
I just noticed. If anyone has any questions, Piyush would definitely be interested in helping out with it. And so, oh, here we go.
We have plenty of time, and I'd love to
Yes.
get any questions. Yeah.
So how far does Perseverance travel each sol?
So that depends. Yeah. So that's an interesting question. So that depends. The thing is, the idea is not to travel fast. The idea is to do the science. So it could be that you wouldn't travel. You would just stay at one place, and then you would just analyze the surrounding. Or let's say you are in front of say 3 rocks, and you the science team decides that you actually want to like analyze all three rocks, then you would just stay there for some time. So again, like the idea is not that you want to like travel as a long distance in a one day. It's more of like what what science you want today. Sorry, what science you want to do in one day. So it's more about that.
Interesting. Okay. Do the people that program the sequence of commands for the uplink file test on a rover on site or on a virtual rover before it is sent to the rover?
Yeah, it's again a great question. Yes. So the answer is yes. So there is a twin basically rover. It's called as I think BSTB. Let me put the link here. So VSTV. So it's a test bed, and that's what it is. So whenever we send, I mean, like whenever a command is being sent, so things actually people try it on the rover, and we make sure again, like as I mentioned, we want to make sure like we are not breaking the rover. We are not sending anything which could actually break the rover. So this is like the rover where it's a hardware. It's a kind of a twin of the actual Perseverance rover. So this is getting tested. It's called as Optimism, by the way. Its name is Optimism.
Okay. So we were having trouble breaking up there just a little bit. Okay. So is there anything powered by solar power on the rover?
No. Well, no, sorry. Yes. The helicopter has, I think, a solar panel on it. That's how I think it is charging its battery. But the rover itself is not solar powered. It, as I mentioned, it has the nuclear source and it has batteries, and the batteries get charged by the nuclear source.
Okay.
Yep.
Evan asks, what was the Mars picture link? I only got this far. Oh, he did put that in?
That was what the link. you put
Oh,
down.
Let me check.
did you?
Let me. Oh, okay. The rover. I think it's the raw images. Like, let me correct it.
Okay, thank you. Okay,
Let me know if this is the link you are looking for.
okay. And now Andrew is asking, what do the Mars rovers move automatically?
I think it does. So it has some autonomy in it. So I think the rover can I think, move autonomously up until certain, I think, extent if it needs to. Again, like I don't know like all about it, but that's what I know. Like it could move, I think, autonomously a little bit.
A little bit.
Yeah,
Okay.
yeah.
So Lisa's wondering, does the rover analyze the soil?
It does, yeah, it does. So what it does is, again, like I don't think it scoops actually the soil, but what it does is it has a grinder on its robotic arm. So what it does is it actually, let's say, the picture, sorry, you have rock in front of you, and what you do is you basically like clean the rock and then you grind the rock, and you put the rock sample, you grind it, you put that inside like the instrument, and that actually I think that is a spectrometer inside it, and that's how it analyzes it. uh, the curiosity does that for sure. Yeah.
Wow, that's amazing. Well, she's also wondering, is the topography of Mars mapped before the rover landed? Was it mapped?
uh, uh, so maybe let me try to interpret that question. So mapped as in like if the topography of the Mars I'm like topography of the Mars um, uh, of the Jezero crater, whether it mapped as in like whether it was analyzed before the rover landed, right? Is that the question?
I'm not sure. Let me see. Lisa, did you want to put that in? She's asking, is the topography of Mars mapped? Was it mapped before the rover landed? And I'm wondering if she's just thinking about like the hills and the valleys and.
If that's the case, then yes. So the thing is like, before actually the rover well, before actually they decided that we wanted to land in Jezero crater, there was a I think there's a huge I mean like rounds of landing sites selection, like conferences, and all the discussions actually went. And in that, actually, everyone I think proposed like which actually landing site we think like we should be landing. And then people actually goes through like a lot of discussions, as in like, let's say if I am saying I think we should land here, then you basically put your rationale on why you should land here. So when we are I think discussing about it, then you would actually map everything, like you would consider what exactly is in that area, or if like what kind of rocks you could actually find in that area. So I believe if that's the question, then yes, the topography of the Mars has been mapped before the rover landed. Even before the rover, the landing site has been chosen.
Okay. And then let's see, do we have anything else? So we have the link. Okay, I think we're to the bottom of our questions. We have a lot of thank yous. Is there anyone else that has a question for us? Any other questions?
And by the way, the rover did send, I think, some audio sounds as well. So please hear that. I can actually post the link.
Oh, that's so cool. Oh, and you had a link too. Let me put in a link you put in about the Moxie earlier, because I don't think anyone else got that one either. We do have one more. Okay. I also have, before you all leave, here's something with the Moxie that
Yes. Um, so this is the handle of Moxie on Twitter, Moxie on Mars. It's actually managed by the Moxie team. And so yeah, if you are on Twitter and if you are interested in knowing about more about like the updates on Moxie, um, please follow us, and then you would get to know like the cool things we are doing with Moxie.
all right. So Lisa has another question. Do you know the wind speed on Mars?
I don't.
That would be
I
interesting to
don't. Yeah.
know. Yes, I wonder. And I'm assuming that the rover was made to be able to handle what that wind speed would be, so it wouldn't topple over, correct?
Yeah. Yeah.
Yeah,
Yeah. Yeah.
that's interesting. Okay.
So I mean, I didn't know on top of my head, so I just like did a Google search. It says like around 70 to 30 meters per second. But again, like I didn't know about on top of my head about the wind speed.
Okay. And then Andrew, can the Mars rover explore anything on Mars, or can they only explore certain parts of the planet?
Anywhere on Mars? Well, they can explore anywhere on Mars if they can actually drive up until those points. But again, like the point is, there are different rovers on like different as in like Curiosity is there, um, right? So it's on a different area. Likewise, Perseverance is in Jezero crater. So and as I mentioned, like those landing sites are chosen based on the geology of that area, that what exactly we could get from that area. So uh, uh, they can actually explore anywhere on Mars, but again, like from going from one place to another place, I mean, like the rover, we also need to make sure that the path we are going to it's safe. If I think it can go safely, then I think it could explore anywhere on Mars.
Okay. Scott is wondering, what is the expected lifespan of the rover?
That I don't know, but that's a good question, because again, I think I will just base this answer on the Mars exploration rovers, MER A and B. So those were sent back in 2005. And the primary mission for those rovers was, I think, just 90 souls. But those rovers explored the opportunity we just stopped working like few years ago. It explored more than 15 years. So you never know. Likewise, Curiosity, I think Curiosity landed back in 2012, and it's 2020, it's 2021, so it's more than 8 years now. So it's still exploring. So I think it's more of like the time um, it could actually like withstand, and it could, I think, stay alive. I think it could um, explore Mars.
That's beautiful. Um, Elise is wondering, and Nathaniel, what type of data is collected each day, and what has been learned so far from the data?
So again, like for the data, it's more like when you initially like land on Mars, you want to make sure that you are safe, and all the instruments are safe. So like I mentioned for Moxie that if the instrument is alive after landing, so the initial things are just spent on these tasks. Like you want to make sure that you are safe. Like for the helicopter, uh, uh, JPL just like released a press release, I think, or I think there's an article I was reading about the helicopter, that the helicopter did phone back Earth. I mean, like phone back Earth isn't like we got the data which actually says that the helicopter is, I think, fine, and then it charged its batteries, and also you want to see where exactly you are. So that's why we are
Oh,
taking
you're
like a lot
breaking
of
up.
pictures. Can you hear me? Okay.
We can
So
hear you
you
now.
also want
Yes.
to, yeah, you also want to see, like, you also want to see, take a lot of pictures of the surrounding area. The other thing is uh, uh, the all the instruments, you also want to make sure like the all the other instruments are has been like completely deployed before you actually start driving. So that's the kind of data we like is basically being collected right now. Like, and again, like as I mentioned, like I would highly recommend to go to, I mean, like if you're interested, you can like go to the pictures, raw images, and you can actually see like what actually going on.
Oh, that's great. So Scott is wondering, meaning, how long is the nuclear power supposed to last?
I don't uh, remember on top of my head exactly the years, but I think it could last like a lot many years.
All right. And he's also wondering, can the Moxie experiments and the soil collections happen at the same time, or does the rover have to do one thing at a time?
Mm, I think no. The reason for that is, so Moxie is one of the instruments which is going to take a lot of power of the rover. So when of course, like when the other instruments operate, they would need some power, right? So when Moxie operates, uh, we basically let all the other instruments basically like go on a break for a day, because we Moxie actually need a lot of power. So, and then once the Moxie cycle is complete, the rover is basically the batteries get discharged, sorry, get charged again, so that once the next like soul is starts, then you actually have the battery in a state where we actually started with. So to answer your question, no. When Moxie is operating, uh, no, mostly no other instrument can operate, because again, like it's because of the power consumption.
Okay. All right. And
Yep.
so Thomas in Alaska is wondering, what happens when it tips?
What happens when it? Oh, you mean like? Uh,
If it were to tip over?
uh, um, I don't know what happens when it tips, but the wheels of the rover. Um, Let me put it this way. So there, the wheels of the rover, it's called as the rocker bogie assembly. Okay. So the idea is, well, I don't have the model of the rover right now, but it's like you have this arm, and then you have these this like this. So your one wheel is here, the other wheel is here, and then your third wheel is here. So the idea is, when you are actually driving on a terrain, you would actually at least have, I think, two wheels on the ground. So that would give you stability, and that would prevent you from tipping. So, but I don't know what would happen when it tips.
We hope that doesn't happen. Yes.
Yeah, but we hope that doesn't happen. Yeah.
But that's a good question. All right. And Scott is wondering, can the rover send pictures back of the stars at nighttime? For example, can it see the Big Dipper?
It can send, I think, picture of a nighttime. Yeah, it can send. Yeah.
Would
Yeah.
it?
So the picture I sent, I showed like in my early slide, it was a sunset, right? So it was taken like during nighttime.
Oh,
I mean, like it was taken during evening. So yeah.
but the constellations would be much different there than here, correct? Because it's so far away.
I yeah, and the other thing is like it's also because of the atmosphere, right? I mean, again, like uh I don't know much about it, so I don't want to comment on that. But it's also because of the I'm just thinking out loud here now.
Oh, that's cute. All right, so let's see here. I think that's all there. I have a Q&A here, but I can't seem to open it. It shows there's 5 questions in there. If you put something in the Q&A, and I haven't asked it yet, put it into the chat because that's what I'm looking at. And I apologize if we're missing you. Any more questions? Well, while people are maybe thinking of questions, I am going to share my screen and show you of 2 more events we have coming up. And the next 2 are to celebrate Women's History Month. So the first one is the role of women in 4 stages of the, oops, let me get that. The role of women in 4 stages of the technological revolution. And this is our own Dean of Science and Engineering, Naira Campbell. And so she is going to be doing a keynote and then have a panel of folks and they will have a wonderful discussion. And so that is on March 8th at 4 to 5:30. And please know that this and each of these 2 that I'm mentioning to you will be saved as links and you can always access them. And then the next one will be one of our, I believe she's a civil engineer, forgive me if she's not, but Dr. Rosalita F will be doing a landing suspensions and materials in space. This is her research. And so she will be presenting on Wednesday, March 24th from 5 to 6. So those 2 events will be sent out as if you receive this as an email, we'll be sending it to the same email. So you have access to both of those presentations as well. So as I pop back here, let's see if we have any more questions. Oh, thank you.
Oh, I just saw like, yeah.
Engineer, I'm sorry. And so anyway, so a few more questions here. How long does it take to get a message from Earth to Mars?
So it depends on the time. Well, not time, as in like it could, I think, vary between 10 minutes, I think 13 or 20 minutes. So again, like it depends on where exactly we are, like where exactly the Earth and Mars when you are actually communicating at that time. So I hope I'm sure you must have seen that video, like the 7 minutes of terror. It has an animation of the actual Mars rover like landing, as in like from entry into the Martian atmosphere, then the descent, then the parachute deployment. I mean, we saw the actual video, but the thing is, that is also called as 7 minutes of terror because uh, that all happens within 7 minutes. And at that time, if you actually send the command back to Earth, it would take like around 10 to 13 minutes. So by the time you actually hear from the rover, the thing has already happened on Mars. So the idea is like by the time you hear that, oh, the parachute actually opened, that actually happened way before you actually got to know. So so again, like it depends on the position of the Earth and Mars as well.
Oh, that's great. Okay. And so how many people are on the Moxie team?
A lot. Uh, uh, there are, yeah, there are, yeah, I think there are a lot of people. So there are like few people from JPL, a lot of people from MIT who are actually operating the Moxie. There are like scientists who actually study the data, like the data from Moxie. So a lot of people. Yeah, it's a group of I think 20, 30 people,
Oh, that's
more than that.
wow. Oh, how beautiful. Well, with that, it is almost 7 o'clock. And so if anyone else has any questions that you're just dying to know, you can send me an email and I will forward them and we'll see if we can answer them for you. But it's been wonderful having you all be a part of this. And we want to thank you too, Piyush. And so we can never thank you enough for all you've given to Merrimack. And we really appreciate
Sure.
it. passion and your understanding and knowledge of all this has been wonderful for all of us. And so
Thank
Thank
you so much. Yeah, thank you so much, Anne, and thank you so much everyone for listening and attending this talk. And again, like, please follow us and the Moxie and the Mars, the Perseverance rover, and you will get to know like the cool things
yes,
on the rover. Right.
That's
Thank you
right.
so much.
thank
Yep.
you.
Have a good night.
The very best with your research. Thank you. Take care, everyone, and have a beautiful evening. Bye-bye.
Bye.
Bye.